Alright, VXLAN stands for Virtual Extendable LAN. I told you it's an extension done to layer 2 technology where you got 24-bit ID now. The VLAN ID is only 4-bit. Listen, VLAN ID is only 4-bit. It is 4-bit. It's just a 4-bit out of 16-bit. That 16-bit includes the system extension ID, the priority, and so on. Sorry, not 4-bit. It is 12-bit. VLAN is simply 12-bit. Out of 16-bit in the layer 2 header, 12-bit is for VLAN and 4-bit is for the priority. All right, now VLAN is only 12-bit. VXLAN is 24-bit. As a result, you get more VLANs, but here we don't call it as VLANs. We call it as VXLAN. The reason is it's not simple layer 2 technology. This is not done on layer 2 header. This is an additional header added to the OSI layer. So you cannot call it as a VLAN. See, even though VXLAN is a layer 2 tunnel, layer 2 domain, we cannot call it as VLAN. VLAN bits are on the layer 2 header itself. Reservation for VLAN ID is done on layer 2 header itself. Whereas VXLAN is an additional layer, additional encapsulation added in between layer 3 and layer 4. So this is a different story actually. Even though this provides a layer 2 tunnel, a separate layer 2 broadcast domain, like we used to have no VPLS, where we got multi-points. Here also this is like a kind of VPLS, but for VPLS you need MPLS. Here you don't need depend on MPLS. VXLAN uses layer 3 underlay to provide a layer 2 overlay. VXLAN Virtual Extendable Local Area Network. This technology provides the same Ethernet layer 2 network services as VLAN does, but with a greater extendability and flexibility. See, the result is same. What VLAN provides a separate broadcast domain with, when we say broadcast domain, we got many ports in same group. Yep, that is how we call it as broadcast domain. So even though it is providing a same layer 2 broadcast domain, but how it is giving is with the help of layer 3 underlay. So for understanding, you can use this word network services, layer 2 network services as VLAN. But VLAN works in layer 2 header. VLAN, for VLAN identification, in .1q header, we have 16-bit. And in 16-bit, we have 12-bit for VLAN. whereas VXLAN is a UDP header. It's layer between layer 3 and layer 4. You see this. Fine. Now, what is next? Instead of calling it VLAN IDs, we will call it as VNID. VNID stands for VXLAN Network Identifier. Each VLAN here we call it as VNI, or you can call it as VXLAN segment. Instead of calling VLAN ID, we need to call it as VNID or VXLAN segment ID. So you got 24-bit, which is going to define the broadcast ID, broadcast domain. Like VLAN, we have VXLAN ID. If I say VLAN 10, what does it mean? It defines a broadcast domain called 10. Likewise, for VXLAN, you have 24-bit to define broadcast domain. Say, for example, I will say 6000. 6000 is one of the broadcast domain in VXLAN. The 6000 is what VNID. You will never see a VLAN number 6000. Because 4094 is the biggest VLAN that you will see. Configurable VLAN. Because the number of bits there is only 12. Now, I have a question for you. Can I use VNID as 10, number 10 as VNID? For VLAN, we have 12-bit reservation. For VXLAN, I have 24-bit reservation. VLANs can be between 1 to 4094. 4096 is the maximum that you will get out of 12-bit. That's somewhere reserved. So 4094, let's say. Now my question is, can I use that VLAN number, the same IDs as VXLAN ID? Can I use number 1000? Can I use number 500 as VNID? Answer me. Can I use number 500, which we also use as VLAN ID? Can I use 500 on the switch as VNID?
In switch, we cannot configure it, right, sir? Because it's a different one.
No,
VXLAN and
no,
one is.
no. Let's say you have Nexus 9000 series switches. They support both VLAN as well as VXLAN. Got it?
Oh, okay.
They support
Yeah.
both. So my question is, can I use number 500 as
No.
VXLAN
No.
segment ID? See, answer both no and yes are correct. Both are correct. Why I'm saying is, listen, VXLAN is a separate header. VLAN is in layer 2.
Yeah.
So definitely we can use number 500 as VXLAN ID. But to avoid confusion, for VXLAN, some operating system allows you only to provide from number 4097 onwards. To avoid confusion. To differentiate between VLAN and VXLAN number,
Okay.
it's the vendor who stops you from using those numbers which are given for VLAN. It is two separate bits, two separate header. We are not sharing any VLAN header with VXLAN.
Yeah, got it. Yeah.
So you can use VXLAN ID or VNID 500, and you can also use VLAN 500. Both should not conflict because they are two different headers. But vendors, they don't allow us to use. But I will not say all vendors. Some vendors, they don't allow us to use the VLAN range for VXLAN. Now, what is VTP? Every switch where the VXLAN starts and VXLAN ends. What is VXLAN? It's a tunnel. It's a layer 2 broadcast domain defined inside a virtual environment. We call it as tunnel, VXLAN tunnel. So the tunnel will start in one switch and end in another switch. Most of the time, we'll use clause architecture. Clause architecture. This is what clause architecture is. If A wants to talk to, let's say A is in VLAN 100, D is also in VLAN 100, and you also have someone called E, which is also in VLAN 100. But this B and C is in VLAN 200. Your aim is to form a VXLAN tunnel for VLAN 100 members. So what I do is I map all the VLAN 100 to VXLAN, let's say 5555. I map. This is VNID. I map this to this. On switch A, switch B, okay, let's say leaf 1, leaf 2, leaf 3, leaf 4. Spine 1, spine 2, spine 3. This is what cross architecture means. Got leaf and spine. So on leaf 1, leaf 2, and leaf 4, I have done the mapping between VLAN 100 and 5555 VXID. All leaves are connected to all spine. All leaves are connected to all spine. So that you can have equal cost multipathing. You see, if you want to go from A to C, you got only 3 hops. 1 and 2. And then at last to C. See, let me repeat again. From here, if you want to go to C, 1 hop, 2 hop, and the third hop. And if you go this path, second switch path, 1 hop, 2 hop, and 3 hop. And the third switch path, 1 hop, 2 hop, 3. So anywhere to anywhere, you will see always 3 hops. So we can do equal cost multipathing. You can do load sharing across all the links. Now coming back to the story. Which story? We were discussing about the VTP. This is what called as virtual tunnel endpoint. Each leaf is a virtual tunnel endpoint. Spines are not virtual tunnel endpoints. Spines are just transit device. Spines are transit device. You don't connect any end devices to spine. None of the end device A, B, C, D, E connected to spine. We call this as clause architecture. But you know this clause architecture is not mandatory for VXLAN. If you will have, it will be nice. VXLAN mostly people use in data center, but it can be also used in service provider. Even in enterprises, if devices supports. So if you go service provider and see VXLAN, they don't follow this clause architecture. We'll be having traditional 3-tier architecture: access, distribution, and core. In that case, you may not have equal cost multipathing, but you will have VXLAN tunnels. So every device where the tunnel starts and tunnel ends is a VTP. It's a virtual tunnel endpoint. Now, to identify each virtual tunnel endpoints, we will have an IP address. I repeat, we'll have an IP address. Say, for example, if I have IP address on this as 1.1.1.1, 2.2.2.2, 3.3.3.3, 4.4.4.4. We call this 1.1.1.2.2.3.3.4.4, between which the tunnels are negotiated as VTP, virtual tunnel endpoints. VTP, virtual tunnel endpoint. These addresses are tunnel endpoints. As I said earlier, VXLAN is a layer 2 on layer 3. You see, VXLAN technology allows the overlay, means tunneling a layer 2 network over layer 3 underlay. So for layer 3, what is needed? IP address and the routing protocol. Now this underlay routing protocol to provide reachability between the VTEP, virtual tunnel endpoint, can be any. As long as we have reachability, we can negotiate VXLAN. Alright, but in data center, we will find mostly ISIS. In this type of environment, a link state routing protocol is better. ISIS or OSPF. In service provider also, we'll have ISIS or OSPF. So coming back to this one. Now I just finished saying what is VTEP, virtual tunnel endpoint. Means that's the place where the tunnel begins and tunnel starts. What is tunnel? Encapsulation. What encapsulation happens? Encapsulation of VNID to the packet. So the packet gets a new ID so that it can be delivered to the remote switch which matches with the ID. So VX segment ID is added on the source switch. We call it as VNI. We call it as encapsulation. On the destination switch where the tunnel ends, we call it as decapsulation. De-encapsulation is removing of VXLAN segment ID. Now, what is NVE, NVI? You remember, whenever you configure any tunneling concept, for example, DMVPN, where do you configure DMVPN? Where do you put all the DMVPN configuration? In a router, where? In which mode? Where do you put?
The IPsec, right?
No, no, no. Where did you configure all the tunnel commands? Tunnel mode,
Inside the tunnel.
inside the tunnel interface, right?
Yeah, yeah.
So without tunnel interface, we cannot do DMVPN. We need an interface because it's an overlay technology. This is the interface. The tunnel needs an interface. The tunnel is not physical, tunnel is virtual. So you need a virtual interface. Here we call that virtual interface, the logical interface, as NVI, Network Virtual Interface, NVI. This is VE, E stands for interface. Don't expect I. Here we already used I, NVID. So this network, you see, network. This V is meant for VXLAN. So here it is virtual. So it should not confuse us. That's why they named it like this. NVE, Network Virtual Interface. This is VXLAN Network Identifier. VNID, NVE. It's different. NVE is interface. Don't look for INVI. No, it's not NVI. Because N and V and I is already used. They don't want to use it. NVE, Network Virtual Interface. It's a logical interface where this encapsulation and decapsulation occurs. Same like where GRE, encapsulation, decapsulation occurs. It occurs on tunnel interface. MGRE means for DMVPN we use MGRE, where the decapsulation and encapsulation occurs on the tunnel interface. Here we call it as NVI. Interface NVI, that's the command. Interface tunnel, like you used to have interface tunnel. Here we will say interface NVI, NVE, interface NVE.
So this network virtual interface NVE,
Hmm.
this interface will be inside the virtual tunnel endpoint, right?
Yeah, on every tunnel endpoint, we need to go and create
Okay.
interface NVE1, interface NVE2. You put question mark, it will show how many NVE you can create. In some devices, they don't allow you to create more than okay, actually, I don't want to say a number and limit because advancement might have been done. So it depends, how many NVE a device supports. It depends on the license. It depends on what device you're working on. So there is a limit in number of tunnels within a tunnel interface. You may have many VNIDs. You may have many VNIDs. So don't say that, if I have 10 tunnel, I can create only 10 VNIDs. You can have 16 million using same tunnel. So there is no connection. But for the number of tunnels that you can create, there is a limit. That will vary from device to device that we need to check. Now, what is VXLAN? As we already saw, VXLAN is a technology that allows the overlaying of layer 2 network over layer 3 underlay. The underlay is layer 3. So you need to have a proper fast converging underlay routing protocol to reach between these routers should ping each other. These routers should be converging faster when there is a topology change. For that, you need any routing protocol recommended. I recommend that instead routing protocol. Now, what does VXLAN uses? VXLAN uses UDP encapsulation, so that you can carry the layer 2 packet over layer 4 encapsulation. UDP layer 4, MAC layer 2. So you can have a layer 2 tunnel. So you can have a layer 2 traffic inside the tunnel, which is negotiated using UDP with the help of the reachability provided by IP. You tell me without IP, can UDP or TCP work? Nope, not possible. Both for TCP and UDP, you need IP reachability. Without having reachability, how we will ping? At the same time, we should not call this as MAC in IP. This is not MAC in IP because we are not doing encapsulation in IP header. We are doing encapsulation in UDP header. This VNID is carried inside where? This VXLAN header. It's using UDP. So it uses MAC in UDP encapsulation. Don't forget MAC in UDP, MAC in UDP. You need to repeatedly say MAC in UDP. Layer 2 in UDP layer 4. So what is the advantage of using VXLAN? What does it solve? VXLAN solves three main problems. VLANs can be only 4,000, but VXLAN you can have 16 million. VXLAN is only 4,000 layer 2 broadcast domain, whereas VXLAN can provide VNIDs. How many? 16 million, because you got 24 bits. You see, you got 16 million to the power of 24 dedicated 24 bit. Whereas in VLAN, even though there are 16 bit, dedicated is only 12 bit, 2 to the power of 12, 4096. So VLANs only can support, you can have only 4096. In that also there are a lot of reservations. Whereas you got here 16 million because you got 24 dedicated bits. 24 to the power of 24, 16 million. Huh? Okay. It's a big number. Definitely, it may not be fully consumed in this today's technologies. Advancement is not going to take all this, but definitely future will be very faster than today, and they may need it. Allows layer 2 to be extended anywhere in an IP network. Come on, understand this is very excellent feature. Extending layer 2 from one building to another building may be easy. You may have some repeaters, you may have some boosting device to boost up the layer 2 signal over the Ethernet wire, and you may have something like that to extend. But extending layer 2 from one continent to another continent, one end of the world to another end of the world. It's not that easy. A lot of technology came in between, in the middle before VXLAN. There are a lot of proprietary technologies like OTV is one of the Cisco's idea to extend layer 2. If you want that OTV, you need to buy special Nexus 7000, which is very costly. And you need to buy license additionally to have OTV. This all no more needed. All that you need to have is a device which supports VXLAN. Not only Nexus, even ASR supports VXLAN. There are many devices supports VXLAN now. You need just a device that will support VXLAN. That's all. And you can extend your layer 2 to anywhere. Meaning, if I send a layer 2 broadcast domain, a layer 2 broadcast packet, say for example, if I send a R packet, R request, that will come to you because we both are in same domain. That R request will come to you. And you can send an R reply. So my device and your device will be in same broadcast domain even though you are not in the same location or country or continent where I am. So anywhere, if I have ping, if I have IP reachability between my router and your router, then I can extend my VLAN, my layer 2 to you, to your layer 2. We can form one broadcast domain. Even though you have different internet connection, different service provider, WAN technology, you may be having MPLS on your end, I may not be having MPLS. Those things are all not matter because we are going to have a tunnel. So that the tunnel will cover all those layer 3 in between, all those technologies like MPLS, MPLS, IPsec or whatever. Everything will be hidden. If there is
Sir,
reachability, then I can have tunnel and I can travel, I can send my MAC header packet, my layer 2 packet over the UDP. Yes, please.
Sir, I have a doubt here. So in that case, if we have like at your home you are having this Nexus device, and at my home I am having another Nexus device, then in that case we will be able to extend the VLAN, a particular VLAN, and then we can converse each other.
Yes, yes.
Okay.
You may be having VLAN 10, I may also be having VLAN 10. Now, what we need to do is in both the side, we need to map it to one common VNID.
Okay.
Let's say 5555. And Mr. Ko also will map it in Belgium and 5555 is also in VLAN 10. So we three will have the same VXLAN segment ID. As a result, we three will form one broadcast domain.
Okay. But that will not be a secured one, right?
For security, you can have an additionally security enabled.
Okay. Okay. Got it. Okay, sir.
So allows layer 2 to be extended anywhere in an IP network. Optimized flooding, meaning you're not going to flood to everyone, you're going to flood only between our three devices. When I send a layer 2 broadcast, it goes to core and it goes to you. And if you're the one who's supposed to respond to my ARP, you will respond. There may be millions of people in this VXLAN, but not all are going to get the packet that I flood. I am a member of 5555. Only those who are in 5555 as a member, they only receive this flood traffic, no one else. Same like what you do in layer 2. When you send a layer 2 pack flooding layer 2 broadcast packet in VLAN 10, only VLAN 10 members will receive it. Isn't it? Same way. The flooding will be within. So it's an optimal flooding. Now, why VLAN, VXLAN? VLAN scalability, VXLAN extends the layer 2 segment ID field to 24-bit, which potentially allows up to 16 million unique layer 2 segments over the same network. Second point, layer 2 segment elasticity over L3 boundaries, meaning wherever L3 is, you can have this L2. That is what we saw in the previous, allows layer 2 to be extended anywhere in an IP network. VXLAN encapsulation encapsulates and layer 2 frame in an IP UDP header, which allows layer 2 adjacency across router boundaries. So the routers in the middle are no more considered. They're all invisible now, because you form a tunnel. You form a tunnel between your router and my router. So the routers in the middle are no more considered as hop. Leverages multicast in the transport network. This is the secret. Leverages multicast in the transport. I told you 5555 is our VXLAN segment ID. For each VXLAN segment ID, we will provide a multicast address. So, using multicast, when I send a broadcast, using this multicast, so when I send a layer 2 broadcast, using this layer 3 multicast, the broadcast will come only to those members of 5555. Because with each VNID, we have one multicast. You can also have one multicast address for many VXLAN segment ID if it is for same customer. We'll talk about that in detail later. Now, what I'm trying to say here is multicast is used to control the broadcast. And see, let's read that line. Leverage multicast in the transport network in order to simulate flooding behavior for broadcast, unknown unicast, and multicast. I gave you an example earlier. ARP. When will ARP flood? Because you have an unknown destination, unknown unicast, unknown destination. In that case, it will flood. In that case, it will broadcast. If a switch do not know a destination, then also it will broadcast. Yes, VXLAN switch will also broadcast to all the members if the destination is unknown. Alright, so you can have broadcast, unknown unicast, and multicast in layer 2 using multicasting. I already told about this equal cost multipathing. If you will have cross architecture, or even in the traditional architecture, if you have multiple paths, multiple layer 3 paths, all paths can be used to load balance, to load share. All right, with this, I would like to stop.